Good evening, my lovely students, and welcome to Raka's mechanics classes. Today we are going to solve a problem based on moment of inertia. So what is that problem? This is the diagram of that problem. Over here, this is the I section. This is the I section available with me. This is the I section for which we have to find the moment of inertia. And what about the dimensions of this I section? These are the dimensions available with me. This is 24 mm, 24 mm, and this is 48 mm. All the dimensions are given to me in terms of mm only. This is 48 mm, and this is 6 mm. This is 8 mm. This is also 6 mm, and this is also 6 mm. And what about this one? This is what about the axis about which you have to find the moment of inertia? This is the axis about which you have to find the moment of inertia. So this is the axis, this is the x-axis about which you have to find the moment of inertia. And what about the dimension of this distance? This is the 24. Similarly, this is also 24 mm. All the dimensions have already told you that all the dimensions are in terms of mm, not in terms of meters. In terms of mm, these dimensions are there. Now, to find the moment of inertia, what we will be doing, we will classify this complete I section, or we will break this I section into various parts. What are those various parts? These are the parts. This is the first part, this is the second rectangular part, and this is the third rectangular part. For this one, as we have break this I section into three rectangular parts, so for that one we have to designate their centroidal axis also. So this is the axis, this one is there, this is the x1 is the x6 centroidal axis of the first rectangular portion. And similarly, what about the x2, this is the, as this is the third one, so this is the x3, and where is the x2, this is the x2. I'm going to designate that x2 also. This is the x2 over here, this is there, this is the x2 over here, as x2 and x6 are coinciding. So as we have drawn the diagram correctly, and we have represent all the dimensions also, we have designated the axis also. Now we have learned that moment of inertia of rectangular portion, of any rectangular portion, we have learned like that moment of inertia will be, this is there, if any rectangular portion is there with me, and these are the centroidal axis. This is the y centroidal axis, this is the x-axis centroidal axis, this is the y centroidal axis. So I-axis we have learned that is equals to bd cube by 12, and if we are going to take this dimension as the b, this dimension as the b, this is the b dimension, and this is the d dimension. So moment of inertia of this rectangular portion, moment of inertia of this rectangular portion about x-axis axis will be what? Bd cube by 12. And what about the Iyy? That Iyy is db cube by 12 is there. Bd cube by 12 and db cube by 12. Bd cube by 12 and db cube by 12. These are the various. This is the moment of inertia of this rectangular portion about x-axis and y axis. Now let's find the moment of inertia of this portion. So for that one, what we will be doing, for that one we will write down the equation, or we will write down the moment of inertia of this complete I section in one single equation. What is that single equation? I xx, that is the moment of inertia of this complete I section about this orange color axis, xx will be equals to what? I x1. I x1 is the moment of inertia of this first rectangular portion about its own centroidal axis, plus a1 and h1 square. What is this complete? This complete quantity is there. We are getting this complete quantity by using parallel axis theorem. by using parallel access theorem. By using the parallel access theorem, we can find the moment of inertia of any object about any given axis. About any given axis, but that given axis must be parallel to either of the centroidal axis. Over here, this x-axis axis is parallel to x1, x1. That's why we are able to use the parallel access theorem, and this is the mathematical statement of the parallel access theorem. What is that? Moment of inertia of this rectangular, this first rectangular about this axis by using parallel access theorem is what? I x1 x1 plus a1 h1 square. Similarly, for this second object, for the second rectangular is there I x2 x2. Over here there is no need of using the parallel access theorem. Why? Because x2 x2 and xx both are coinciding, and we can say that xx is passing through this xx centroidal axis of the second rectangular portion. This xx axis is passing through the x2 x2 centroidal axis of this second object. So for that one there is no need of using the parallel access theorem. Similarly, for I x3 x3 plus a3 and h3 square will be there. For this third object, where is the third object? This is the third object, this one is there. For that one also we have to use the parallel access theorem. Now we can put the values also. As we have learned, these are the formulas are there, bd cube by 12 and db cube by 12. So we will be putting those formulas over here. Ixx equals to what? Over here bd cube by 12 plus b dot d, then h1 square for the first object, plus for the first object I'm going to write down over here, subscripts are there, then bd cube by 12 for the second. Similarly, bd cube by 12 plus b dot d, then h3 square, then this is for the third one. Now we can put the values also. After putting the values, what are the values? B is what? Over here B is this one, as we have taken B this one, so B is this one. What is that B? 24 into what is the D? D is what? 6 cube by 12 plus 24 into 6 into 27 square. How we are getting this 27? That is what h1 is there. What is that h1? This is the h1. What is that h1? This is the h1. Basically this is the h1, distance between the two given parallel axes, h1. What is that h1? How we are getting 24 plus 3? This one is 3. 24, this is the 24, this one is the 24 plus 3, this one, the smaller one, half of that 6, that is 3. So 24 plus 3, that is 27. Similarly, what about the h3? This is the h3. h3 is again 27. Now we got the h3 as well as h1, so we can put those values over here also. Now we are getting this one also, bd cube by 12. What about the b for this one, second rectangular portion? For that second rectangular portion, b is 8. And what about the d? D is over here 48. Cube is there, then 12, again bracket will be there. Then what about this one? For the third rectangular portion, b is 48. What about the d? D over here is 6 cube by 12 plus b is what over here? 48 dot 6 dot 27 square. Then this bracket will be there. After solving, we are getting values also. What are those values? These are the values that this one, this complete value we are getting as over here. This is 432. We are getting this one as the 432. We are getting this one as the 432. This value we are getting as the 104976 after calculations, plus 73728 plus 864 plus 209952. After adding this one, we are getting this complete value also. What is that complete value? We are getting as 38. Ixx we are getting as 388952 raised to the power 4. This is the final answer. This is the final answer. Thank you, folks. Once again we will be meeting.